Hello everyone, hope everybody is doing well. In this video, I would like to introduce a very interesting deep learning tool or application, what you say, named TorchStudio. In this video, we are going to learn how to access the various datasets are available in TorchStudio related with Torch Vision as well as the Torch Audio. Based on the dataset we have selected, we could build multiple of these models by selecting either the pre-built model or a pre-built model trained completely and it's ready to be used as a transfer learning model. We can also use another classifier which is built within the TorchStudio and by updating its hyperparameters, perform the training, and finally, based on our selected dataset and the various different training setup by using the different pre-trained as well as the just model classes, we can validate the training results, and that's all is going to be covered in this video. As implied by its name, the TorchStudio is a wonderful application for someone who would want to use the majority of the applications, samples, examples, pre-built models, everything included in that scenario coming out from PyTorch, and they are all included in this application named TorchStudio. You can get the TorchStudio just by visiting torchstudio.ai, and you can download the pre-packaged builds for the TorchStudio depending on your operating system. Currently, it supports Windows, macOS, Ubuntu, as well as the Fedora. I had downloaded the TorchStudio for my Mac, and as you could see that it's going to install the Python environment, and about projected size is about 5 gig at a particular folder. If you would want, you could actually change a folder. The installation has been completed. So I have just started the TorchStudio. As you could see that this dataset tab is open. Here are the preferences in the settings. You could see that this TorchStudio is using Python 3.9 and all the Python libraries related to PyTorch are installed here. If you would want to add more Conda packages, you could add directly here. And if you would want to open the terminal, which is related to this runtime, you could use there. So here the Python is already running 3.9.13 and it's coming out from the Conda version, basically the mini Conda to be exact. And here you can actually add the remote servers. It means if you have access to other remote Python servers which are available and you have access to, then you can use username, password, or the SSH key to connect those Python environment. And these environment could be running on Azure, AWS, Google, or even your local machine. Here, I am running this TorchStudio at my Apple Silicon based MacBook. So I have local metal acceleration, but it also supports the local CPU, both for training as well as the inference. So these are the few settings which comes with it. Next, I wanted to show you that where the data is loaded related to TorchStudio. Here you can see that TorchStudio is installed in my local machine, and if looking at the depth level 1 size of my machine, you could see that the Python folder is about 2.2 gig and the data folder is about 5.5 gig. So that's the place where all the file system and the data sets related to TorchStudio applications are going to be installed. Because I have already used this TorchStudio for various test scenarios, so I already have some of these data sets are downloaded. So we could look into these data sets, and the size of these data sets depending on which data set I have are visible here. Going back to TorchStudio, you could see that this TorchStudio runtime is actually created using mini Conda, and which is for macOS because that's where my machine is. But if you are using Python, Ubuntu, or the Fedora, then you are going to use a particular version of Python specific to your operating system. TorchStudio full code base is open source and actively in development. You can always look into its source code And depending on your interest, you can also learn more about its functionality and its integration with all other packages and services. There are thousands of datasets available with thousands of models. We have already seen the local and remote server connectivity through the settings. When we look towards models, we can visualize them, and if you are training, we can actually compare the training and see the actual real-time training results, as well as the compare various training statistics. Here you could see the dataset, and in this list we have datasets related to Torch Audio, Torch Vision, and TorchStudio. Here you see the TorchStudio built-in dataset. It means that you can also add the custom datasets here, like your own, or you can use one of the existing one, either from Torch Vision or Audio. If we are selecting the Torch Vision, you could see that various datasets are available here. Most popular MNIST, and there are MNIST and COCO, so very ImageNet, various others, CFAR, 10, 100. So these datasets are available for you to access them. And if we look into the audio datasets, here are datasets various, and if you have very basic understanding of Torch Audio, the most popular sample application is the speech commands. Here you could select the speech command dataset as well. So now we will look into the TorchStudio datasets by selecting dataset from Vision as well as the audio. So first I will select the MNIST. Here is a code related with the MNIST dataset, some of the information. Here for the dataset, the root is data and is going to be loaded into my local folder. So data at the local. It means the local location where the TorchStudio is installed, and the data folder is where this data folder is created. It means that when you try to download this dataset, it will be downloaded and available in this data folder. Because I have already downloaded the MNIST folder, so the download will be very fast for us. However, I just wanted to let you know that whenever you are going to download a particular dataset, it will take some time. As you could see, the data is downloaded, and this data, if we just want to make sure that training data we need true. Reason we are using download true or false is that because if you are doing the remote training and if you would want to perform everything remotely, you could say do not download. Looking into the MNIST dataset, you could say that we are using 100% of dataset, which has 60,000 training samples and the 10,000 validation samples. It's like almost everybody know about it. We can look into the tensor type. Input is a bitmap because all the images are the bitmap, and the tensor one is the label. So how we are recognizing the bitmap and labels, it comes here. Here you could say that each image is a 1 by 28 by 28. That's our input image. You can actually adjust them depending on if you have images bigger and smaller. If you want to check these samples, here you come into the sample training set, and you can actually use left and right mouse, which will give you the different samples. If you would want to use the validation set, you can do pretty much same thing. So this is your training and validation data checking. Here at the bottom, you can see this is a multi-class data set selected by itself, and you can very quickly analyze it. So when you click this analyze button, actually you are using this parameter usage. It means analyze this data set based on given usage. I will click here, and because our data set size is really very small, about 70-80 meg, it shows that there are 10 classes. The class randomness is 93%, and if looking into this, the analysis was done very quickly. If you had a very large data set in gig, this analysis would have taken long time. Next, if you would say that you would want to analyze the data, but you do not want all the full data set, you can say I'm interested to use only 50% of the data set. Depending on what your usage criteria is, training and validation can be also adjusted. So you could say that you would want the 90% of the data set based on given 50% of usage, 10% for validation. That can be done. Now if you run the analysis, your analysis is done very fast. If you would make this data set to really very small, you would want maybe 10%, you could run the analysis, and that's your analysis. So depending on what usage you are going to select, it will show your class distribution as well as the class randomness. One thing I just wanted to show you while you are here is that if you would want to perform a transformation in your incoming data set, you could actually run the transform here. Right now you could see that our input images are 28 by 28. If you would want to change for a particular reason because you are using a pre-trained network, you can actually run the transformation here. You can say transforms dot resize. You need to know that this transforms dot resize is part of transform module, and here you could actually say resize. You would want to change the resize here, and you say I would want 64 by 64. So after changing this resize, you reload the data set. Sorry, I made mistake, it's transforms. Now you see that because we have resized this image, now our tensor size is 64 by 64, and looking into this graph, you can actually validate that this is 64 by 64. If you would want to change this data set to something else, so for example, we decide to use the CI FAR data set. This is another data set, and I will try to load it out because I have already downloaded this data set earlier. So download time was really very fast. And here you could see that this data set is also about 60,000 total samples, 17% based on this distribution. Here it also similar to MNIST, bitmap and labels. And here if you would want to see that how many classes are there, we could actually reduce this to very quickly for 10% or 20%, and our analysis will be fast. Here you could see that this CFAR 10 dataset actually has the 10 classes, and here each image is 32 by 32 with 3 channels. I'm just using my mouse to make sure that we could see these images. And if we would want to change these samples, we could figure it out depending on our class, such as automobile or truck or ship. Transformation can be done. If you would want to change these images to black and white, you can also change the channel here. So depending on the PyTorch transforms, all these transformations which are available here, you can actually use them in this transform area just by using the comma. So for example, if you would want to run a transformation to resize the images and you would want to add the grayscale, we could look into grayscale. That's the grayscale change. Here we could compose, we could say transform.grayscale, output channels are 1, and we can also do a transforms here, resize, and we can resize this 32 by 32 to 64 and use the comma here. So now you are running the 2 transforms here. Reload the data set. As you could see that our image size became 64 by 64, and all these images are grayscale now because the channel became 1. So this is how you could transform the input data depending on your need. After we have covered 2 vision data set, I will take you to the Torch audio data set, and I will be using speech command. And for this data set, because I have already downloaded this data set at my local machine, looking into this speech command data set, you could see that this data set is about 2.7 gig. So it's very large data set. So if you try to run analyze, it will take some time. Looking into this data set, here is the speech command data set, and here are 35 classes in this data set. Looking into this, you could see that the labels here, input is a signal. Here we can look into various samples, and these are the different samples at 16 kHz. And now we can perform the analysis. I will change this size to very small. Let's make it 10%. Run the analysis. Because it's a 10% of overall data usage, it means that this time is really very small. Otherwise, it would have taken about 5 minutes. So this data set had 35 labels, and that's the distribution or the class distribution and the class randomness. So you could understand the distribution of data for the available classes. As we have seen 2 different kinds of data set, now we can go ahead and spend some time in the training with TorchStudio. It would be easier for us to select a data set related with Torch Vision. So I will be selecting the very popular and known data set, MNIST. Let's remove this transformation. And right now you see this is a 1 channel. It means that 1 channel 28 by 28 image. So it's a grayscale image. And here we will change this usage to 20% because our objective is just to understand how TorchStudio works. So very small data set. Now I will use this plus button which will open a model. Now you could see that we have access to Torch audio model, Torch vision models, and within the Torch vision models, we have several models in various classes such as detection, segmentation, video, quantization, as well as the optical flow and the TorchStudio models. If we look into TorchStudio models, there is already UNet 1D, 2D, as well as the MNIST classifier is available. When you create a model in TorchStudio, it uses the dataset which was loaded previously. Now I will give you a little more information about these Torch Vision models. So if you look into the Torch Vision models, you are going to see a list of models here. Here you see there is AlexNet and there is a AlexNet. This AlexNet is a pre-built model. So if you select this pre-built model, you could see its code. That's a pre-built model code, everything. And if you would want to download this pre-built model, you can actually select whether you want weights as well as or not. If you would select this AlexNet, which is defined here, this is the Torch Vision model AlexNet, where you could define this model. Here you could say that this model is defined with the number of classes. It still is using the AlexNet model, but here you could configure it, we can build it, and let's see what happens. So if we select AlexNet model, for example, so you see there that input to the AlexNet is an RGB image with a 256 by 256. What we could do, we can come here, we can resize 256, reload the dataset, move back to 10%, analyze it. Let's go to model, reload it. So we have expected input here. Okay, so we got this. So now we need to channel it. Let's come back here, comma, transforms dot number of channel 3 channels, 10%. Based on that, we could go and use this model and say, okay, let's reload. At this point, at least you could see that we were able to successfully load the AlexNet. One big problem here is that because AlexNet output are the 1000 classes. But remember, our data set which we are using has only the 10 classes. It means in order to make this AlexNet model work, we have to change number of classes to 10 and we have to again rebuild this model. This time we can look into at the bottom and you can say that the last output is the 10 classes. It means we have matched that part if you would want to use the AlexNet. We can see that our hyperparameters, these are hyperparameters is we are using the loss as the cross entropy. Our metrics is accuracy we are using. Optimizer is the atom. Batch size is 128. There are 100 epochs. Metric is going to be monitor, which is the accuracy will be here, and here will be our loss. Display validation set. So depending on validation set, we could actually see these images. Early stopping is there, and what I will do in the epochs, I will just change it to 10 because we just want to see how everything works. So I have changed epochs and I'm also using the early stopping, so it might even take less than 10 epochs. It's going to use the local metal acceleration, means the MacBook Apple Silicon. Let's start the training. Training has been started, and here are some of the issue related with Apple Silicon. So what I will do is that rather than using metal, I will just change this to CPU and let's start the training again. There are a couple of ways to fix that Apple Silicon problems, which I'm just not trying to come and explain here due to time limitation. And as there are no errors, we could see that our training has been started successfully. Let me go ahead and stop the training. Now I will go ahead and I will build a new model. So this model has been selected, configured and ready to build. But because of resource limitation, I'm not going to go ahead and build it. I will select the another model. As you could see, this is the model. By default, it's just copying this model configuration. And here I will be using a different model. So let's do one thing, select the MobileNet version 2. And this time we are using the pre-built model. Here is the pre-built model code. Let's run this build and see what happens. Model has been built. And if you look into this model, you could see that now you could see that when we have selected AlexNet, this is the AlexNet network. When we have selected this MobileNet version 2, here you could see that this model is actually a little more complex and it's not the linear comparative to the previous one, which is quite linear model. So in this scenario, when we have selected the MobileNet version 2, this pre-trained model shows, again, as you see, there are 1000 classes as output. So we really have to fix this similar to what we have done here with this model by changing here classes. So here you see that this model is not the pre-trained one, this is the pre-trained one. And one very good feature of TorchStudio is that you can actually edit these layers properly. So I will be clicking the linear here. You could see that this line has been added, neural network.linear. Input features are 1280, which is coming out from this dropout, and then output features are 1000. So I have to change it to 10 here. Once it is changed, we have to rebuild this thing. And as you could see, this linear, now it's generating only 10 output features. Those are the 10 output features depending on our 10 classes here. If we compare this model and this model, you will see quite different settings depending on the network type and the model we have selected. If you would want to perform the training, we could actually perform the training here. Here, most of the features are same for the hyperparameters, similar to model 1, which is the AlexNet. If I try to say go ahead and start the training, you could see that after the caching, if there is no error, we will believe that our training is good. So far, no error. It takes some time to start the first epoch. And while this training is being on, I didn't stop the training. I will go ahead and use the MobileNet version 2 model, but without the pre-trained, so it doesn't have weight, etc. It just has the definition of the class. So here is the model 3. This training is still going on. So I will come back to model 3. Here I'm selecting the Torch Vision model and MobileNet version 2. Here is the code. The previous exercise which we have done here by changing the output features 10 here, I will go ahead and I will change that here because we can directly change here. If you look into here, this is actually copied from the previous one, so it may not be correct until we have to rebuild this model. Let's rebuild it. After we have built, now this graph is updated, and here you could see that this is showing the correct 10 output classes. This training is still in progress, but because it's a CPU based training, it's going to take really very long time. So I will just go ahead and stop it. In this model 3, if you would want to change these parameters and perform the training, we could actually do exactly the same. But I just wanted to show you that how you could load the data set and perform the various kinds of training by selecting a particular model and by making certain modifications as needed, either in the model class or in your data import. So make sure everything is work depending on your need. One thing I wanted to just show you that with the AlexNet, we had to update the image size from 32 to 256 by 256. However, with this MobileNet, we may not really need it because the MobileNet does support the minimum image size from 32 by 32 all the way to larger size. For that reason, this whole experimentation with 3 different types of MobileNet as well as the AlexNet model types did work. In the next step, while we are still using the same MNIST dataset, I will go ahead and I will use another model, and in this case, I will be selecting the TorchStudio model, the MNIST classifier. Let's look into the code. So here is the code related with this MNIST classifier, and we are using the MNIST dataset. Let's look into the model 4, and here we will just try to reload and see what happens. And the first problem, as you could see, that this MNIST classifier is designed for the image size not 256 by 256. So for that reason, I will go ahead and I will change this back to 28, change channel back to 1 channel, data is loaded. Let's make this to 10%. Now here, let's load this model and everything went well. So depending on this network is set If you would want the dropout here, as you could see that there are the dropout here applied, dropout here applied, but we do not see the dropout here. But if you would say that, okay, let's use the dropout here, true, rebuild. Now this network has these two dropout built into, and at the very last we are using the softmax as the activation. So depending on your initialization of all the layers and the construction of your feed forward network, because this is the definition and this is the network design. So that's our very small network. So if we will try to do the training, it will be quite faster. So I will go ahead and change the epochs to 10. I will keep everything as it is here, and I will come back to local metal acceleration, train it. All these samples has been cached. We received this error related with dropout. So I will go ahead and make this dropout to false, rebuild it. Now we have no dropout, epochs are 10, and let's run this training. And as you could see that our training has been started. And reason I selected this option because it was easier for me to show based on the resource I have. Our training has been completed, and as you see that training has been stopped and only few epochs were there. So I will go ahead and I will make this 25. So it resumed where we stopped. More iterations. Here you could see that in the loss validation versus training. So loss value is going lower versus our accuracy is going higher and higher. And because our sample size is really very small, 10%, so it doesn't matter the correctness of our model. So I think our objective to show the trainings has been completed here. Now I'm going to take you to another feature of TorchStudio, is accessing its dashboard. Here, as you could see that we have selected these 4 models, but we only train one. This training is still going on. It's running, but it's not showing any progress. And these 2 has already been stopped. So looking at the dashboard with regard to this particular experiment, we have built 4 models, 1, 2, 3, 4. 4 actually using the MNIST classifier, and it achieved at least some significant result. However, rather these 3 models has no result because we already know that they really didn't run anything significantly. Here status is shown, and here you could see that where we are as of now with regard to model number 4, because that's the model number 4 color. I will go ahead and stop this training. I will come back to model 1, and here now remember in order to get the LXNet working, we had to update this image to 256, and we also need to have 3 channels. Let's reload this data set, make it to 10%, analyze, come back to model 1, and I will stop the training. So here what I'm trying to do is that as you see that there are dropouts layers in this LXNet. So I'm going ahead and I'm removing this dropout. So there is no dropout. As you see, the dropout option has been gone from here. Configuration, let's rebuild it. So we are not using any dropout here. Then we are going to use the same hyperparameter setting. Let's use the CPU, and after some time when the training is going to be completed with few epochs, we can see that 2 different model results are listed in this dashboard. So that's all I had for you in this video. I hope you have enjoyed the content. I do appreciate your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.